Hi, in this video we are going to create our own AutoGPT chatbot that uses custom knowledge base. It will also be able to use other tools, like it will be able to send emails or Slack messages. And we are going to do this by using Langchain. Langchain is a large language model framework. So on top of the large language model, we put Langchain that allows us to do more exciting and more interesting things than just large language models. So instead of just prompting a large language model, we will be able to connect different tools and our own custom knowledge database. Let's first understand what we are going to do. We need to create an agent, and I will explain in a moment what agent is, that will be able to listen our commands and decide what it needs to do. For example, if I ask it for information, it should be able to understand that it has to search for the information in the custom knowledge base and give me the answer. If I ask it to send the answer in Slack or in email, it should be able to understand that it has to use the email tool and send me what it answered before. Agents are able to take actions by themselves to achieve the goal that user inputs. And the actions are limited to the tools that we give this agent. For example, if we give the agent the opportunity to send emails and search a custom knowledge base, it will be able to perform only these two actions. If we give the agent the Wolfram Alpha API and Search API, then it will be able to search in the internet and perform some mathematics. And we are going to try everything today, both create the custom knowledge base and also give an agent a tool to search internet and perform math. And this is all possible with Langchain, a large language model framework. This framework is available both on Python and JavaScript. Today we are going to use Python because it's just easier to explain the concepts using this language. But then you'll be able to create your own full-stack applications or with Python on the backend or with JavaScript. To perform an action, agents need to use tools. And you can think of tools as plugins in ChatGPT that are going to be released soon. But besides these tools, agents are also able to use your own custom knowledge base. And let's also first understand how they can do so. I already had a video where we were creating a chatbot with a custom knowledge base. But there we were only using custom knowledge base. We didn't use other tools. And if you only need this functionality, I advise you to watch the previous video first, because that technique is much more simpler and much more faster. So we were using GPT index that is now called Llama index, and it was very fast to create this chatbot. Langchain is a little bit more difficult and we have to understand more things that are going on there. But on the other side, it's much more powerful. We can create agents, and also we can tweak every little thing. And today I'm going to show you how to do that. Now let's return to custom knowledge base. How do we let the large language model know our context? So if I'm asking the large language model something about my business, for example, how it will be able to know what to answer? Especially if you don't want to get a generic answer, but the answer is specific to your business. One simple way to do this is just to feed all the context information to the large language model. So together with the prompt, you are also sending context information. And it might work if you have very little information, so not much. It will work perfectly and you'll get your custom answer. But what if you have a lot of information? Then you won't be able to fit everything to the large language model. You either hit a token limit, which means that your data is too big, or it will be just too costly for you. Even if you don't hit the token limit, it will be just expensive to run such queries. So we have to do a trick to let large language model know the context, but don't feed all the data at once. And we can do it with indexes. Index is a way to store your knowledge database. In Index, all your data is split into small chunks, and every chunk has a semantic meaning. This meaning is stored in vectors. When a user makes a query, we search for relevant vectors. And when we find those vectors, we also find the relevant chunks of information. Then, instead of feeding all our custom knowledge base in one query, we take only relevant chunks and give it as a context to the large language model. Now, large language model is able to answer the questions based on the relevant chunks that we provided. Alright, enough theory. Let's build our own agent. I've prepared the collab doc for you that you can find in the description. And now we are going to review what is going on there. So let's first install the dependencies that we are going to need. It may take a while. Dependencies are installed, and now we have to set our OpenAI API key. You can find your keys on platformopenai.com. In your account, you go to View API Keys, and here you can create a new key. So let's create a new key, and I'm going to delete it after the demo. So you don't have to copy it, create your own. I put it here in environment variable and just run the code. Second, we also have to prepare our API keys for Pinecone. What is Pinecone? Pinecone is a vector database. You remember that our chunks have vectors, and we have to store these vectors somewhere. And to do this, we are going to use Pinecone. I'm also going to show you how to do this without Pinecone but with ChromeDB, because currently Pinecone got so popular that they made a waiting list for free accounts. So you might not be able to use it right away. You have to join a waiting list, and only then they give you the access. But the benefit of Pinecone is that it stores your database, so you don't have to think about how to store your database. And that's why we are going to use Pinecone, but I will show you alternative tools. To get Pinecone API keys, we have to create our first index. So let's do this. We create index, and I will call it demo. We have to set the dimensions. I'll set 1536. Closing, and so that's it. We just create our index. Our index is ready, and now we can go to API keys. Here we have environment and the API key itself. We have to copy both. So first I'll copy the environment and put it here. And I will also copy the API key. And I'll also put it here. We enter the key and run this code. Next, we have to create index with our custom knowledge base. And for this demo, I'm going to use the PDF from InVision that I found on the internet. But you can use many different files to create an index. Last time, a lot of people were asking me if they can use CSV, if they can use URLs, text files, many different types. So yes, you can use different types. Go to the documentation, and I provided the link to the documentation to the relevant page. And here you could see that document loaders. And there are so many different document types that you can load for your index. We are going to load PDF, but as you can see, there are so many types. You can even load Figma, for example, or Markdown or Notion. There are many different types. Just go to the documentation and figure out how to load the documents that you have. In our case, we are going to use PyPDF loader and just load this PDF. For this demo, I'm not going to store it anywhere, so I'm just going to put the PDF directly to the files in the collab environment and call it from there. Keep in mind that this is a temporary solution because collab environment won't save your PDF file. So once I reload everything, it will disappear. But for demo purposes, it's more than enough. So I'm just going to load this PDF into Pages. Let's see what Pages is. Pages is the list of documents that has page content, and also it has metadata with the source. In our case, we just had one PDF and the page number. And for every page, we have our own document. So let's delete this as we don't need it, and go to the text splitter. Now, when we loaded the documents, we have to split it into small chunks. And there are many different ways to split documents into chunks. Again, just go to the documentation and explore what are the different ways. We are going to use recursive character text splitter, which is a recommended way to split general text. And in the documentation, you could go here to see what it does. It splits the chunks based on n character. N is a new line character. But there are much more text splitters that you can explore. Langchain says that recursive character text splitter is okay for general text. So let's believe it and run. I have actually tried also semantic splitter, and for my queries I didn't find any difference, but maybe because of my queries. Maybe if I would ask the large language models something different, I would see the difference. But in my case, I didn't, so I don't think how important it is. I would advise you just to experiment on your dataset and on your queries and see what works best for you. Then we have to create embeddings, and now we have to create a vector store. I'm using Pinecone, but I'll also show you another technique if you don't have access to Pinecone. To use Pinecone, I have to specify index name that you can find in your index. So this is the index name. We specify it here, and then we create our new vector store. Let's run this code and see what happens. Nothing happens in the collab environment, but let's go to Pinecone and see what has changed. Here we can go to index info, and we see that we have added new vectors to our database. Now we can use them to find relevant chunks in our custom knowledge database. So let's return to the Pinecone, and I'm also going to show you the alternative way, an alternative database. So this was Pinecone. Pinecone is a paid tool. So for more indexes, you have to have a paid account. But you can use an open source tool that is called Chroma database. And it is free. You can use it as much as you want. The downside is that you have to store the database yourself. For these demo purposes, you don't have to store your database anywhere, because you can just create it once, have it in temporary memory, and use it before you close your computer. But if you want to build an application with it, then you have to store it somewhere. But for demo purposes, you can just don't run this code, but run this code. You uncomment it and run this instead. And then instead of doc search database, you will have the DB database, although I will call it the same doc search. So you run either this with Pinecone or you run ChromaDB. And then if you run this code, when we call doc search, we will query this Chroma database and not Pinecone database. So it's either Chroma or Pinecone. Don't create two databases. It's absolutely unnecessary. By the way, there are also more ways to create vector stores. Again, I've provided the link to the documentation. You can go there and explore other ways to do that. Now vector store is ready, and we have created ours in Pinecone, and we have to query it and see how it works. My file was about design operations, and it had a chapter about design ops support model. This chapter that explains what is design ops support model. And let's see how it will be able to find relevant chunks. So at this point, we query the vector store and we find relevant chunks. We don't construct a human answer yet, we just finding the relevant chunks. And let's see how it works. We have our query, and we create the documents that store the relevant chunks relevant to this query. And I'm asking to print the length of the documents, so how much chunks do we have. I'm asking to print the first document, the full document, and I'm asking to print just page content. And let's see what it does. So we have 4 documents in total. So for every query, we will have 4 relevant chunks, not just one, because it might be not the best answer if we find just one relevant chunk, but 4 relevant chunks. And every chunk has its page content, and it also has the metadata. So if we scroll somewhere further, we will find metadata. So metadata stores page number and source. In our case, we just had one PDF, so we have just one source, and it also says which page it is, and it finds the relevant chunks. The relevant chunk. In this case, I've asked it to print just the first one, but keep in mind that we have 4 of them. And when we create our agent, the agent will use all 4. But now we just printed the first one. It has page content and metadata. And if we query docs 0 page content, we can just access the chunk content itself. So that's how it works. And now we have to create a chain that will be able to give human-like answers based on the chunks. The chain will get all the docs that we have just seen, and it will compose an answer based on these docs. Again, as with other steps, there are many different ways to create chains, and there are many different chains. You have to go to the documentation to see other chains. In our case, we are going to use question answering with sources, although in agent we won't use sources. But you can also see how to keep these sources, this metadata that I've just showed you. And you could see that in Langchain, you can create many different chains and also many different ways to create question answering chain. It can be just question answering, can be with sources, can be even retrieval question answering. So different ways you can experiment what works best for you. We follow the documentation and create our chain, and I've called it QA, question answering. The chain is created. By the way, here you can specify your large language model. In my case, I'm using OpenAI, and I'm using the default model that I guess is GPT 3.5, but you can specify the model here. You can use GPT-4, you can use ChatGPT, and so on. Again, you have to experiment and see what will be cheaper for you and still will produce good results. Now, when we have created our chain, we can run it to see that it is working. I'm going to give it the same query and see the result. Awesome, this chain composed an answer based on the docs that we have found. Let's run our previous codes to see the difference. I'm going to comment these lines because I just want to see page content probably for the first document and see how close it was to the document. It found the relevant chunk, but as you could see, it's not exactly the same as the output. The chunks are not the answer, it's just relevant context information, and our chain is now able to compose the answer based on this context information. And that's great. We are done with the most difficult part, which is creating an index and creating a question answering chain. Now we have to create an agent, and you would be surprised that creating an agent is actually much more simple than creating an index. So the most difficult part for me was to understand how to connect my index to the agent, because in the documentation it wasn't really obvious how to do this, and now I'm going to show you how. For my agent, besides the index itself, I decided to use the Zapier tool. And you can use many different tools. You can use also search, Wolfram Alpha, as I said, and many other different tools. If you go to agents, and if you go to tools in Langchain documentation, you could see all the different things that your agent can use. For example, it can use Google search, it can use Zapier, and I think this is the most exciting tool because it actually connects you to everything else. And you can use Wikipedia. You can use also human as a tool, which is very interesting, I think. So human as a tool is the ability for a large language model to ask you more questions. So when we're creating AutoGPT, instead of just trying to use other tools and just trying to solve the task that it was given, the goal that it has to achieve, it can also ask you follow-up questions to come up with the answer. But we don't need this, we are going to use Zapier. And Zapier is the application that connects other applications. There are tons of applications that you can use with Zapier. Let's have a look. We have to go to Zapier Get Started, and you have to create an account there, probably again join the waiting list. I'm not sure how they are doing it now. But once you get there, you can get your personal API key and manage actions for Zapier. As you could see, for me, I've connected Gmail, and in Gmail you can connect specific actions. For example, I've connected find emails, but I might also connect search for emails. I also connected Slack, so my agent will be able to send Slack messages if I ask it to do this. And for Slack, I've connected the direct messages and channel messages. I've also tried other actions. For example, I've tried to connect Google Sheets, and if you go and create, for example, a new action, you could see all the apps that you can use. And there are many. For example, for emails, you have Gmail, but also MailApp, Outlook, MailChimp, somewhere there, Zoho email, many. You see, just for the emails, you have so many different tools. You certainly will be able to find what you are using. For example, if you store your data somewhere, there is a high probability that you can find this tool also in Zapier. And to explore all the tools, you just go to Zapier.com and go to Product, App Integrations, and you can see that there are more than 5,000 apps that you now can connect with your large language model. So the opportunities are limitless. You can connect to Airtable, to Calendly. For example, if you want to be able to schedule the meetings, you can connect your Zapier to Calendly. And then your Langchain agent will be able to access those tools to schedule a meeting when you ask it to do that. Let's go for a moment to actions again. When you create a new action, you have to connect your account that you are using in the other app that you are connecting. And then you have to specify what Zapier has to do when the action is invoked. For example, you have to specify to whom you want to send an email. So this action is sending email, and we have to specify to whom. And you can just use a specific value. But in our case, we can say that we want to AI guess to whom we want to send the email. Same with subject and the body. For all of these, we said have AI guess. So these fields have to be filled by the large language model itself. Alright, now you know how it works. Let's connect it to the Langchain. I've already showed you how to get your API key. And then we have to get a toolkit from Zapier to our agent. Let's see for a moment what toolkit is. I have prepared a code for you just for demonstration purposes. The list of different tools corresponds to the actions that I've just shown you. And here I'm asking it to print the first one. As you can see, it has the name Gmail Find Email, absolutely the same that we have seen in our actions. It has the description that is used by large language model to understand how to use this tool. And it also has other things that are specifically needed for Zapier. I wanted to show you how these tools look like, but in fact, we don't need this piece of code. And now we are ready to build our agent. We have our index and we have our Zapier toolkit, and now we just have to assemble it into agent. To do that, you have to follow the documentation, and I've provided several links because it was a little bit tricky to understand how to assemble it all together. It's in different parts of the documentation, but the logic is very simple. We have our agent and we have the tools. The first tool is our index. I've given it name, demo, and the function is QA run. You remember when we created a question answering chain, we called it QA. And now I am putting it here in the tools. I've also provided the description, although here I would advise you to experiment. I found that my description doesn't work as I would like it to work, but it's like with every other prompt. You have to experiment to see what works the best. So here is our index, and here is our Zapier toolkit. You remember that when we created Zapier toolkit, we called it toolkit, and now we just have to get tools. I'm also creating a memory for my chatbot, so it remembers what I said before, so I can query it several times. And I'm just assembling it into one agent. I would say this is the most simple part. Again, to understand more, go to the documentation and read what's written there. For my agent, I'm setting verbose true, and it will allow me to see how my AI thinks. So when it is choosing the tools, when it is observing what it gets from the tools, I can see everything that it does. If verbose is false, then I will see only the final answer, and I won't see the thought process. Now we have to run this code, and we are ready to query our agent. I'm excited about this part because I'm using this PDF as a knowledge base for the first time, so I'm not yet sure of what answers it will give me. The first one is the one that we already ran with just our QA chain. What is design ops support model? And what I wanted to do is to use our custom knowledge base. And as you could see, it didn't work. My agent thought that it is smart enough by itself to answer this question. Now let's just try to adjust our query to make it use our custom knowledge base. The good news is that if you have a very specific custom knowledge base and large language model haven't seen this information during its training purposes, then it will use your custom knowledge base. You don't have to adjust anything. But in our case, let's try to make it to use custom knowledge base. I will try to ask it to not make anything up. And let's ask it to use context information. Let's try one more time. No, it still gave us the generic answer. So there are two reasons for that. First, we haven't used the prompt template. And second, I think the PDF was also very generic, and there is a lot of information like this available on the internet. But let's see what we can ask it, maybe something more specific. Yeah, it's the publicly available PDF from InVision, and I guess they've also used this information for their articles for SEO, and that's why the large language model knows the answer and decides not to go to the knowledge base. Let's try to find something specific. Maybe we can ask something very specific. For example, what this guy or girl have said about design ops. Let's try this. Let's try this query and see if it will use finally our custom knowledge base. Yes, it's actually using it now because it doesn't know the answer by itself. So during fine-tuning, it didn't have this information, and now it goes to our custom knowledge base and get the answer. And this is actually not the first time when I encountered this problem, that the agent decides not to go to the custom knowledge base, but decides to answer by itself. And yes, we should try to create a prompt template that reshapes the query, so we instruct our agent to use for context information. But as you have seen this time, it ignored my instructions to use the tool. And I'm not sure why. This is actually an emerging field of prompt engineering, when you try to engineer your prompt so it works as you want. And we cannot expect the users to prompt engineer their queries. We have to do it on top of their queries. But from my experience, agents are not yet reliable. You've probably seen a lot of exciting demos on Twitter, but keep in mind that these demos was creating with carefully calibrated queries. And agents are not always working like this. Sometimes they even go in a loop, and probably we will see how they go in a loop in a second. So yes, if you want to have a bulletproof solution for your custom knowledge database, then I would advise you to use just the QA chain without the agent, because QA chain always uses your custom knowledge base. It doesn't make up answer by itself, but an agent has more freedom to decide what it can do, and that's why it not always does what you want. But things will certainly improve in the future, and we have to be ready to use it. So let's try to query again our agent. And this time I will ask it to send me an email with the answer that it got from the previous query. Alright, it understood that it has to send an email. It understood to whom it has to send the email, constructed the body, and constructed the subject. Now it says that it has sent the email, and let's check. Yes, I have the email with the answer that I get from the previous query. So my agent has a memory, and it understood that it has to send the answer from the previous query to my email. That's it for indexes and agents. I also want to show you how to create another agent with different tools, so you understand how it works. And I have prepared a different collab for you that I will also share in the description. This time we won't use index, and index is actually the most difficult part of Langchain, because assembling agents is actually quite simple. This time we will just assemble agents with other tools. And I won't run it because otherwise the video will be too long. I have to explain you how to get the Zapier API key and Wolfram Alpha API. So if you want to have a more detailed video about this agent, let me know in the comments. Now I'll just explain you what is happening here. Here I am creating an agent that is able to use Google search, and it is able to use Wolfram Alpha, which is the application for math. Again, I need to install the dependencies. I have to provide all the API keys, and no index this time. We go straight to building an agent, because for these tools we don't have to prepare anything else. We just have to provide API keys, and when we specify the tools, we just call them Google Zapier and Wolfram Alpha. And that's it. We don't have to do anything else. Other things we already discussed in the previous document. So we are specifying the large language model, we are creating a memory for chatbot, and we're creating an agent itself with tools, large language model, and memory. And that's it. Now I can query it and make it use the search and math, because these are the tools that I've provided. For an example query, I am asking it to find the weather in Amsterdam in Celsius and calculate the natural logarithm from the answer. No practical application for this query, I just did it to see that it is using Wolfram Alpha and Google Zapier. You can run it yourself to see how it works. I'm also giving it a second query to find the flights for this weekend. And when I ran this code, my agent got into the loop and wasn't able to provide me with the answer. As I've already told you, agents are not reliable. Don't just believe the fancy demos on Twitter. Sometimes it works, sometimes it doesn't. And that's it for this video. I've put a lot of effort to make it, so please give me the like and subscribe to this channel.